Hello, everyone. We are a mining consultancy that has provided independent professional advice to mining companies, providers of capital, law firms, and government agencies for over 30 years. Staffed by senior industry consultants with extensive international experience, we are here to discuss relevant topics for the benefit of our mineral industry followers. And now, here is your host, Micon's Mineral Resource Specialist, Alan San Martin.
Hello everyone, I am Alan San Martin. Happy New Year and welcome to Micon Insights, formerly known as the Micon Hour. We are now excited to provide you with an informative and engaging discussion that will help you to know more about our capabilities. Before we begin, this is our sustainability statement. At Micon, we work with our clients to promote responsible mining and to integrate the principles of sustainability into their mining projects. The topic for today is titled Open Pit Mining Requirements Vary with Study Levels. I'm here today with my colleague and co-host, Kerrine Azougarh. She's based in Toronto office. Kerrine is the principal mining engineer with Micon. Hello, Kerrine. Thank you for co-hosting today at Micon Insights. How are you?
Good, thanks. Thank you for having me, Alan.
Great. So if we want to know more about you, can you please tell us about your mining background?
Sure. My mining experience starts with, I'm a mining engineer with a Bachelor of Science from the University of Alberta in Edmonton. I have plus 25 years experience in open pit mining, which includes operating mines for 11 years throughout Alberta, Ontario, and Newfoundland. And in those operating mines, I worked in coal, oil sand, iron ore, and palladium. And I've been in consulting for over 12 years throughout Alberta and Ontario. I joined Micon International recently, and I'm very happy to be here. I also had a couple 2 years of short-term contracts in the late 2017-18 in Ontario. So I've worked on many global projects. In the Western Hemisphere, I've worked on projects in the Americas, so Canada and US, Guyana, Suriname, Peru, Chile, Bolivia, and Brazil. And in the Eastern Hemisphere, I've worked on projects in Africa, like Liberia, Madagascar, and Mozambique. And in the Middle East, I've done a project in Oman, and then also projects in Australia.
Okay. Thank you, Kerrine. Very impressive background.
Thank you.
Yes. So if we start with the very basics about this topic about surface mining, what are the common surface mining types?
So there's three main types. There's open pit, strip mining, and quarrying. So I'll just give a bit of each of those. Open pit is generally used for mining in hard rock and for metal mines. And it can be on mountains, hills, or flat ground. Strip mining is generally used in soft rock and is often called open cast or open cut. And found in mining, you can soft strip mining, you find coal, oil sand, and soft phosphates.
Yeah.
Then the third is quarrying, which can be in mining of dimension stones such as marble, granite, sandstone, and limestone. You see these in your daily life with countertops made from these mining products. And also quarrying includes aggregates such as sand, gravel, and crushed rocks. So these aggregates can be found in mountains, hills, or flat ground, such as gravel in the form of riverbeds. And the dimension stones can be on exposed sides of mountains or hills.
Yeah. So you mentioned a lot of uses of all these products. So the main commodities that are mined in a surface mining method. So what can you tell us more about that?
So there's several different commodities, many actually. They include things like base metals, such as iron ore, copper, nickel, magnesium, cobalt, tin, titanium, aluminum, lead, zinc, and a bunch more. Then there's precious metals, That includes gold and silver and platinum group metals, which is acronym is PGMs. And that includes platinum, palladium, rhodium, iridium, ruthenium, and osmium. And so then the third group is energy metals. That includes minerals that are used to generate energy, such as coal, oil sand, uranium, and lithium. But it does not include petroleum. And then industrial minerals are minerals such as aggregates, diamonds, gypsum, talc, and many more that are used in different industries for many products.
Yeah. So if we start digging more into the actual studies, because the title of this episode is Level of Studies. So can you elaborate more about what are the studies in project development?
Absolutely. So we're going to look at two sets of studies. There's the project development studies, and that includes scoping level or desktop studies.
Yeah.
PEAs, which stands for Preliminary Economic Analysis. There's PFS, which is a preliminary feasibility study. Then there's FS, which is feasibility study, and then EPCM, which stands for Engineering, Procurement, Construction, and Management. So those are all the developmental stages before a mine begins. And then the other type is after production starts. And those are due diligence reviews, DDs, and independent engineering reviews, which we call IEs. And so I'll go into further detail of each of these type of studies now.
Okay.
The concept studies are the scoping studies and desktop studies. These can be on properties that are greenfield, which means that they're new and never been mined before, or they can be on brownfield properties which have been mined in the past or are currently being mined. Conceptual studies are used for in-house documentation of high-level studies. They're short exercises to determine within plus or minus 40 to 50% accuracy of what value may be potential on the property. And at this point, a mill feed is not considered ore, which is an important part, and we'll look at that throughout the different stages. So then we go to, once we've completed that study, if things are looking good and there have been no fatal flaws that have been identified outright that would kill the project in the first scoping study, you would want to proceed into the preliminary economic study or analysis. And that includes mineral resources of class categories of measured, indicated, and inferred. And the inferred resources can be considered in the analysis, yet the mill feed is still not considered ore at this stage, as the inferred resources do not define well enough, or not defined well enough to encourage or for economic valuation. So PEAs are done to plus or minus 30% accuracy level, and they're used to develop plans that aim to determine whether future studies should go ahead. If the results obtained are compelling, then the company should proceed to the PFS stage, which is more detailed and results become more reliable. So we're going from 50% accuracy down to 40% accuracy, and now into the PFS, preliminary feasibility study, you're looking at 20 to 30% accuracy. So in preliminary, or the PFS, it's designed to provide company stakeholders with key information on logistics, capital requirements, and key challenges. This is needed to help guide decision-making through the process. And PFS is a critical step in project development. So it's where we do excuse my lips, conversion of a mineral resource into a mineral reserve. And up until this stage, the mill feed was not considered ore, but at the pre-feasibility stage, this becomes a mineral reserve. And so you can call it ore in reports publicly. And in Canada, we are we have CDAR, and for public trading, all our documents are placed on this site, and they control it's SEC. And so that's where we have to follow CIM guidelines to make sure that we're conforming to mineral reserve and mineral resource standards and definitions. And so inferred resources can no longer be included in the economic evaluation at the PFS level, but they can be discussed separately as a future opportunity as part of the waste that can be have opportunity if there's any further drilling that could change them from inferred to indicated or measured. So from this study, if it's a negative result, they may head back to the drawing board, delay or abandon the project entirely. But if it's positive, then the next step would be a feasibility study. So the FS follows PFS. It's the most detailed and comprehensive study that we would do in a project prior to the funding being committed. This would determine whether to proceed with the project by developing the parameters for geology, engineering, legal, operating, economic, social, environmental, all these areas to be considered for the company to have more certain confidence of the success of the project. And then feasibility is done to a 10 to 15 plus or minus accuracy. And this is a final stage before development begins. And it includes necessary detail on what terms the company should lend, or what terms the financier should lend to the company. Also determines whether the project's profitable and how much capital will be required. It allows the bank and the engineers to determine if the risk is acceptable and confirms the project is viable. And so often FS is often referred to as BFS or DFS. But in Canada, we refer to it as an FS. But the BFS is a bankable feasibility study, and a DFS is a definitive feasibility study. And these terms are used in other jurisdictions and countries like the UK and potentially JORC. But for Canada, we use FS. And then the last development stage is the EPCM. And in this stage, we finalize the designs, permits, and approvals, start the purchase orders. The quotes from the feasibility stage have details that fleshed out. The long lead items are ordered early on to avoid delays. Things such as mills, shovels, trucks, and even sometimes tires, depending on the market supply and demand. I remember one year that tires were severely in demand and were taking a couple years to get ordered. So one of the mines that I worked at had a loader, brand new loader that sat there for months as they were waiting for tires.
Okay.
So,
all right.
And then the other thing that's in the EPCM is the construction. That begins on the site with constructing of facilities, such as the construction camp to support all the people that are doing the construction. Also power lines and substations, mills, buildings, tailings dike, and access roads. And then finally, the project management is key to the smooth transition from feasibility to EPCM. The owners oversight with their own project manager, perhaps, but then there is a project manager, project management team, and they manage the several contractors and consultant groups that work on the project together. So it's a large team that requires a lot of oversight and working together, managing the schedule and details in full. So that's it for the development studies. Then the production studies, we have the due diligence reviews, and that's a short time span of usually 1 to 4 weeks, and it includes a site visit of the specific relevant experts, and they'll do a review of client data, have collaborative meetings, and report on the findings. And that is often done for mergers and acquisitions or for bank funding. And then the other study is independent engineering, and that is where you represent a financier or a bank on a project. It's an unbiased report of technical aspects of the project, and that could be anything from looking at fatal flaws in a technical review. It can be reviewing the engineering design and technical inputs to the financial model, or assessment of project participants in the project site. And it can also be contract reviews of non-legal documents, such as who's doing the construction of the site. Then there's operations, maintenance, and environmental reviews, construction and performance monitoring, monitoring of compliance with specifications, or annual operational and maintenance reviews. So these can be short-term reviews of a week or two, but they can also be of long-term of over a year or several years of a project.
All right, Kerrine, this is a very, very detailed insight of all the levels of studies. And clearly to our audience, we in Micon, we create or make these studies or help you to make these studies with our expertise. So the question is, what are the typical traps that happens in this project development?
Well, traps that we often see, a lot of junior or exploration companies, they're kind of strapped for funds. And so a lot of times we'll see them skip studies or combine them to save money up front, potentially trying to rush to early production and take advantage of a market boom that's happening at the moment. The problem with skipping different levels of studies is where too much time and money can be spent in a beefed up scoping level study, putting too much detail up front before understanding the fatal flaws and drivers. And that could waste money on a project that will never get started. Or you can do too much work without having identified the fatal flaws, key drivers, or options that could save the company millions over time just to save thousands up front when trying to get funding for drilling. So, but getting the right geology at the beginning is crucial to a project. So determining where to drill next to increase measured and indicated resources, because the inferred resources don't get funding. They only identify other potential areas that require further drilling, drilling programs, and money could get to the measured and indicated. So those kind of get fleshed out in the early stages, and then the bulk of the engineering decisions to streamline it for the feasibility are made in the PFS, where you do trade-off studies identified in the scoping and PEA level. Could be major things like geotechnical studies of the entire project, or the pit slopes, the tailings area, where your facilities are being built on, things like that, hydrology, environmental studies. So the options are fully evaluated in the PFS to find the best scenario, the one scenario that will be identified for detailed development in the feasibility study. And lastly, the most costly decisions are made when studies are skipped purely on a basis of today's market instead of the life of the mine and the company's long-term goals, when adequate time isn't allocated to find the best choices.
Okay, so if we start wrapping up this, what would be the Micon's final word of advice in project development for surface mining?
Well, I would say it's so important for each project and each company to hire the right people in their own company and as their consultants and contractors with the right scope of work for each phase to make sure they get the right work done upfront as needed to meet the project needs of all the stakeholders, not just shareholders or potential to grasp the potential funding they could get today when they need to develop more to get the appropriate full-scale mine. And these studies are all within the capability of MICON. We either have the experts to do the work, or we partner with others in studies such as feasibilities and EPCMs to cover all the expertise needed. So it's this is pretty much what we do in a nutshell.
Yeah. All right. Thank you, Kerrine. So I'm now going to open the microphones for our audience here joining us on Zoom. You can ask questions to Kerrine about this surface mining development studies. Please, if anyone would like to ask questions, you can ask now. Unmute your mic and go ahead. Well, while people is deciding to ask a question or not, I have a question.
Sure.
When you describe all the different levels, you said about the accuracy level or a percentage of accuracy. How do you arrive to those accuracy percentages?
The level of detail that is required for each study, in terms of a scoping level, maybe a month's worth of work. A feasibility study, maybe 6 months worth of work, and the PEA and pre-feasibility are somewhere in between. EPCM can be a 2-year project. So, there's several years from the beginning to the end of these stages, and it depends on the project size, what type of project. You can have open pit, you can have underground, you can have open pit and underground. You kind of need to determine from the geology that is there what method is best for getting it out of the ground, but also processing it. That part's not my expertise, but the getting it out of the ground is in terms of open pit. But I've worked on several projects where there's open pit with an underground either at the same time or after the open pit is finished. And sometimes you'll have the development of an underground going in an open pit that's being mined at the same time. You can have open pit that's truck and shovel. You can have conveyors. You can have electric or tram trucks. There's such a variety of different types of mining methods. And underground is a completely different thing from open pit, and they're both very complicated. And they both have quite a lot of different technology that goes with each of them. So, but the geology, I would say, is the most important thing to get right at the beginning. If you have weak geology or wrong geology, it can kill your project, or it could tell you there's a project that doesn't actually exist. So it's very critical to get the geology from your drilling and exploration programs done right.
Yeah, the way I put it is that the mineral resource is the foundation of all the mining work that can be developed, because it's embedded all the geology and the knowledge of what is in the ground.
Yeah. My work doesn't start until the geology is done, and
exactly.
Also some of the geotech has to be done as well before I can do anything past a scoping level. Scoping level and PEA, we can actually make some assumptions, but once you get into PFS and feasibility, you have to do the first
principles studies.
First principle engineering to get the numbers. You don't just benchmark or make estimates. Okay, so the cost between all of those is quite different, and so is the timeline, and therefore so is the accuracy.
Yeah. Kerrine, thank you. Well, last chance. If someone in the audience joining us today can ask questions, you can do it now. Okay, I'll take this as no questions. So, Kerrine, thank you so much for being here with us today.
Well, thank you for having me. I enjoyed it.
Okay. Well, if you want to say something to our audience before we go.
Oh, just thank you for listening, and we hope that you consider Micon for your open pit mining and geology projects. And we look forward to meeting you and working with you.
Excellent.
And thank you for hosting, Alan.
Thank you, Kerrine. Thank you.
And Nicole for support.
Yes. So thank you, everyone. We are now ending this broadcast. Thank you for being here with us and have a great day. All the best.
Thank you for joining us today. We hope you enjoyed this episode. Please feel free to leave your comments or questions, and be sure to follow us on LinkedIn and subscribe to our newsletter so you're kept informed on future episodes.